Hello student, today I am going to discuss the topic critical section and the problems and the solution of the critical section. Firstly, we should know what is the definition of a critical section and what does the critical section mean. When more than one processes access a same code segment, that segment is known as critical section. Critical section contains shared variable or resources which are needed to be synchronized to maintain consistency of data variable. In simple terms, a critical section is a group of instructions or statements or region of code that need to be executed atomically, such as accessing a resource like file, input or output port, global data, etc. Consider a system consisting of n processes, and each process has a segment of code called a critical section in which the process may be changing common variable values, updating a table, writing a file, and so on. In this, we cannot assume how many n processes are being competing to use some shared data. We cannot assume what is the speed or the number of CPU will be. And each process has its own segment in which the shared data is being accessed. The basic problem is that how to ensure when one process is being executing in its critical section, no other process is being allowed to execute in its critical section. As we have discussed, the critical section in different threads are not necessarily in the same segment. In concurrent programming, if one thread tries to change the value of shared data at the same time as another thread tries to read the value, that is, the data race across threads and the result is unpredictable. The solution to the critical section problem must satisfy the three following requirements: mutual exclusion, progress, and bounded waiting. In mutual exclusion, if a process Pi is executing in its critical section, then no other processes can be executing in their critical section. In progress, if no process is executing in its critical section and some process wish to enter their critical section, then only those processes that are not executing in the remainder section can participate in the decision on which will enter its critical section next, and this selection cannot be postponed indefinitely. In bounded waiting, there exists a bound or a limit on the number of times that other processes are allowed to enter their critical section after a process has made a request to enter its critical section and before that request is granted. So, in it's critical to understand the importance of race condition while writing the kernel mode programming, since the programmer can directly assist and modifying the kernel data structure. When a process executes code that manipulates the shared data, we say that the process is in its critical section, and the execution of a critical section must be mutually exclusive. At any time, only one process is allowed to execute in its critical section, so each process must first request to permission to enter in its critical section. The section of code which is being implementing this request is called the entry section. The critical section might be followed by a leave or an exit section. The remaining code is in the remainder section, and the critical section problem is to design a protocol that the processes can use so that their action will not depend on the order in which the execution is interleaved. It is a basic structure, general structure of the process while entering into the critical section. The critical section program is basically is to design a protocol that the processes can use to cooperate. Each process must request to permission to enter in its critical section, and the section of a code implementing this request is the entry region, and the critical section may be followed by an exit section. The remaining code is in the remainder section. It's clear? Today we have discussed the critical section and the solution of the critical section. The solution is that to synchronize the different processes, we have to follow that we have to satisfy the following condition of mutual exclusion, progress, and bounded waiting. Entry section, critical section, exit section, and remainder section will be the four sections which each process will going to be follow while entering into the critical section, and after completion of the work they have to exit the section, and remaining processing of that process will be happen in the remainder section. That is, the remaining program remaining part of the program will be in the remainder section. Thank you. Now, in depth, we are going to discuss the solution of the critical section problem, as three requirements that has to be correctly followed are mutual exclusion, progress, and bounded waiting. In mutual exclusion, if process Pi is executing in its critical section, then no other processes can be executing in their critical section. Whenever one process is entered in the critical section, then there is no other process can enter in the critical section. Only one process can be executed at a time. That means the other processes are being not allowed to access the critical section, and this particular situation is known as mutually exclusive. The critical section with the help of this mutual exclusion, the critical section can be better be focused and easily be used, and no infinite loop will be there. And if process somehow halts or wait in its critical section, it must not interfere with the other processes. In progress, if no process is executing in its critical section and there exists some processes that wish to enter their critical section, then the selection of the process that will enter the critical section next cannot be postponed. If only one process want to enter, it should be able to. If two or more processes want to enter, one of them should succeed. And in bounded waiting, a bound must exist on the number of times that other processes are allowed to enter their critical section after a process has made a request to enter its critical section and before that request is granted. Assume that each process executes at a non-zero speed. So no assumption can be concerned relative to the speed of the CPU of the end processes which are being executing in the system. The types of a solution to the critical section problem are: there can be a software solution, hardware solution, operating system solution, or a programming language solution. Software solution is that the algorithm correctness should be there, so that we can rewrite our algorithm. Hardware solution rely on some special machine instruction. Operating system solution provides some functional and data structure to the programmer through system or library calls. And in programming language solution, the linguistic constructs provided as a part of language.